Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture today, I am going to discuss about the problem-solving question discussion on alpha-beta pruning. So in my previous class, already have discussed one or two problems related to Minimax algorithm. Now we'll discuss the advanced version of Minimax algorithm is nothing but the alpha-beta pruning. So after the completion of this course, students can apply the bounded look-ahead strategy to predict the future states for decision-making in gaming application. This is the course outcome which students will understand after the completion of this course. Now let me discuss what is alpha-beta pruning and few important points we need to consider to solve the problem, because this video is related to we will solve one problem related to alpha-beta pruning. So alpha and beta, these are, as the name it implies, alpha-beta pruning. Pruning means cutting. So here we will cut something. So what we will cut here, instead of actually in the Minimax algorithm, we used to search, we used to explore all the nodes of the search space, which takes lots of time. So to overcome that problem, we can use this alpha-beta pruning mechanism where it will cut the unwanted leaves. Not only it cut the unwanted leaves, it may cut the whole branch also. Thereby it can decrease the time as well as the cost of the search process. So, and why the name is called as alpha-beta pruning? Because here we consider two threshold parameters. One is alpha, another one is beta. That is why the name of the algorithm is called as alpha-beta pruning, because we are cutting the trees using this alpha and beta. So that is why it is the advanced version of Minimax algorithm. We may get the same answer, but with minimum time, with minimum cost. Now, these are the important points we need to consider while solving this alpha-beta pruning algorithm. So, two threshold parameters, just now I told two threshold parameters we have to consider. One is alpha, another one is beta. So, alpha denotes the max value, which worst case is minus infinity. Beta denotes the mean value, which worst case is plus infinity. At the max level, update the value of alpha, beta remain constant, and at the mean level, update the value of beta, alpha remain constant. Because here both the players will play opponent to each other one after the other. So whenever we'll explore the max level, there we have to update the value of alpha only, beta will not change. And when we'll explore the mean level, then we'll update the value of beta, no need to change alpha. And while backtracking, why this backtracking method is used in alpha-beta pruning? Because it follows the depth first search technique. That is why while backtracking the tree, the node value will be passed to the upper node. This is very important. Normally students used to get confused with whom the value will be compared. So whenever we will do the backtrack, the value of the node will be passed to the parent node instead of passing the value of alpha and beta. And we will only pass the value of alpha and beta values to the child node. Alpha beta value we can move from parent to child, not from child to parent. But node value can be passed from the child to the parent node. These two things, if you remember, everything will be solved. And one important condition here, as the name is called as pruning, how we can do the pruning here? One condition needs to be checked, that is called as if alpha is greater than is equal to beta. For every single node we need to check. Wherever the condition is satisfied, there we have to cut the tree. No need for further exploration. Even one node is kind of satisfying alpha is greater than beta, then in that case that node as well as its subnodes also, everything will be removed from the tree. Thereby, it can decrease the search process, time of search process as well as the cost of the exploration. So this is what the algorithm for the alpha-beta pruning, as it follows the depth first search. Here only considers the nodes along a single path from root at any time. And alpha and beta, these are the two threshold parameters. Alpha is the highest value choice found at any choice point of a path for max player, which is considered as minus infinity, and beta is the worst case value whose value is plus infinity, and pass the current value of alpha and beta down to the child node. update the value of alpha and beta during the search process. That means max updates the max node, max updates the alpha node, alpha value, and mean updates the beta value, and prune remaining branches at the node whenever this condition is satisfied. Alpha is greater than is equal to beta. Now we'll solve the problem based upon the alpha-beta pruning. So as I discussed already, the algorithm also. So it is a two-player game, and especially it is used to solve the problem like chess, checkers, or the Ludo game, or the chess game. This type of problems can be solved using alpha-beta pruning. Now here two players, one is max and min, both will play opponent to each other. So to solve this problem, initially we have to assign alpha and beta. As I told, here we are considering two parameters, alpha and beta, and alpha whose worst case value is minus infinity. Beta is the parameter for min player whose worst case value is plus infinity. These two we need to initialize first, and one of the condition is alpha is greater than is equal to beta. This condition we have to check for all the nodes. If the condition is satisfied, there we have to cut that branch or cut that leaf. Now let us and this tree can be explored from top to bottom. Even though the utility values for the terminal nodes are given, but we have to explore from top to bottom, and it follows the depth first search technique. Already we know that in DFS backtrack is there, because it will explore to its complete depth, then it will backtrack, then it will explore the complete right side part. So like either you follow right or left, that is up to you. Now initially we have to assign the value of A as minus value for A. For this node, let us alpha is equal to minus infinity and beta is equal to plus infinity. So as per the DFS algorithm, the value of alpha and beta needs to be passed to the B node, because in our algorithm already I have told here the value of this, we will pass the alpha beta value to the child node always, right? So the same thing here I will do. We'll pass the value of alpha and beta for node A, which I have initialized, that will be passed to the left node. So that means alpha here it is minus infinity, and for beta is a plus infinity. Now explore after B where it will go. Here for 2D node, same thing, same value will be passed. Alpha is equal to minus infinity, beta is equal to plus infinity. Now after this I cannot pass to 2. Now I have to do the comparison, okay, because the terminal utility values are already given here. So once we reach the D node, and D is a what type of node? It is a max node, okay. So max node means which value needs to be updated as per our algorithm? Alpha value should be changed. How we can change the alpha value? So here what is the alpha value here? Minus infinity. And what is the child node? 2. So minus infinity and 2. Who is max? So 2 is max. Initially first it will be changed to 2. After that this 2 gets compared with 3. Who is max? So 3 will be maxed, right? So this is the way we can change the value of alpha for D node. But we should not touch about beta. Beta is for minimizer, because D node is present in a max layer. So that is why alpha value will be changed, beta remain constant. Now you might be thinking, what is the node value? These are alpha beta value, which are the threshold values for alpha and beta. But what will be the node value? Always you find out the node value by comparing the node value of the children. So what is the node value here? D is having 2 child, one is 2, another one is 3. So between 2 and 3, who is max? So 3 is max. So node value of D would be 3. Here inside, let me write so that you can recognize, you will not get confused. Which one is alpha beta value, which one is the node value. Now, once we got this node value, what I have to do after so because of this DFS, we have to backtrack to the parent node B. So when we will reach parent node B, which value will be updated? Because it is a mean layer or mean player, so beta value will be updated. So beta value, while comparing this beta value should be compared with the node value, not with the alpha beta value of D. Compared with the node value of D, because D is the child of B. So this infinity gets compared with this 3. Then which one is the minimum? 3 is minimum. Let us change to 3. Now no, there is no E value. So now alpha for B node, alpha is equal to minus infinity and beta is equal to 3. Now we have to explore the right side of B. Now same alpha is equal to minus infinity and beta is equal to 3 will be passed from B to E. Now, after reaching here, we have to, which value will be changed for the node E because it is a max player. As it is a max player, alpha value will be changed. So, minus infinity gets compared with a 5. So, who is maximum? So, 5 is maximum. So, minus 5, minus infinity gets replaced with 5. Now, you compare this condition. I hope it is satisfying. 5 is more than is equal to 3. Alpha is greater than is equal to beta for the node E. So, once it is satisfied, we should not explore further. So, we have to remove this branch from our exploration. We will not touch that branch of E, means another child of E, which is given as 9. Now, what would be the node value here? Node value for E, only one child is there. So definitely, as it is a max player, only one child, no comparison. So the node value of E would be 5. Whereas alpha beta value, alpha is 5, beta is equal to 3. Now B value, now you can find, now the node value of D is 3, E is 5. Now you can find what would be the node value of B. B is a mean player. So minimum between 3 and 5, it would be 3. Now we got the node value of D, E and B. Now come to, so B complete tree is over now. Now come to the node A. So at the node A, which value will be replaced? So as the node it is a max player, so alpha value will be changed. With the comparison, with whom it will compare? It will, the alpha value of A gets compared with the node value of B. So which one is max? Minus infinity or this 3. So minus infinity is maximum. So minus infinity will be replaced with 3. Now alpha is equal to 3 and beta is equal to infinity. Now this value will be passed to the right side path. Now we will explore the right side path. So here the alpha is equal to 3 and beta is equal to infinity will be passed from the node A. And how to explore C now? Left side path we will move. Alpha is equal to same alpha beta will be passed from parent to child. Alpha is equal to 3, beta is equal to infinity. Now we have to change the value of alpha for the node F because F is a max player. So 3 value will get alpha is equal to 3. It gets compared with the left child, that is 0. 3 and 0, who is max? 3. So no need to change. Again 3 and 1 gets compared. 3 is max, so no need to change. Then find out the node value of F. So what is the node value of F? 0 and 1. How to find the node value? Already I have told. Node value should be calculated by comparing the children. Children, 2 child are there. One is 0, another one is 1. So max is 0. Between 0 and 1 is 1. So F, the node value of F would be 1. Now this value will we have to backtrack now from F to C. Now at the C point, at the C node, which value will be replaced? Because C is a mean player, so beta value will be replaced. So infinity gets compared with the node value of F, that is 1. Infinity or 1, which one is minimum? 1 is minimum, so replace infinity as 1. Now what we have observed, I hope you might be thinking, this condition is again satisfying. Here alpha is 3, beta is 1. So here what we have to do, we should not search the further. We should not search the further or like child of C. That means this path will be discarded from the search process. As this path is discarded, all the children of this path also gets discarded. No need to touch now. So what we have got here, alpha is, so what now you can find out what is the node value of C, because this path we are removing, only one child of C is there, that is 1F, whose value is 1. Definitely the value of C would be 1. Now what you can find out the node value of A. Node value of B is given as 3, node value of C is 1. What would be the node value of A? Because it is a max player, 3 and 1. So node value of A would be 3. So this is the way we can solve the process. Now you can find out which one is the optimal path in this solution. So this 3 we got from this path, then this 3 we got from this path, this 3 we got this path. So this path is the optimal path using alpha beta pruning and whose maximum value is 3. I hope you might have understood how we are exploring. Like we are considering two important parameters. One is alpha and beta. Alpha we are initially minus infinity, and beta we are initializing plus infinity. Both alpha and beta values should be transferred from parent to the child, and while backtracking, the node value will be passed from the child node to the parent node. So this is the way, and at the max layer, alpha value will be updated and the min layer, beta value will be updated. So by using that concept, we can solve any minimax or alpha-beta pruning algorithm. Now let us solve another problem. This problem is looking like bit complicated because many utility values are given, but the same concept we have to follow. So initially we are assigning the alpha is equal to minus infinity and beta is equal to infinity, and we have to check the condition alpha should be greater than is equal to beta. So this alpha and beta which we have initialized for the node A, we have to pass to the node B. So alpha is equal to minus infinity, beta is equal to infinity here. Same to node D also, alpha is equal to minus infinity, beta is equal to plus infinity. Same here also, alpha is equal to minus infinity, beta is equal to plus infinity. Now at the node H, we have to compare which value needs to be changed. As it is a min player, beta value will be replaced. So infinity, beta value is infinity, gets compared with 10. So 10 is the minimum. Again 10 and 11 gets compared, 10 is minimum. So now infinity will be changed to 10 now. So now here you can observe what is the node value of H now. Node value of H would be 10 and 11. Compare which one is minimum. 10 is the node value. Now backtrack to the node D. At the node D, which value will be changed? Because we have, I forgot, actually we have to check that alpha needs to be greater than is equal to beta. If it is satisfied, then we have to prune. So at the node D, what we have to do, like alpha value will be changed because it is a max player. So what will happen? This minus infinity gets compared with the node value of 10, a node value of H, which is equal to 10. So on minus infinity and 10, which one is max? This is 10 is maximum now. Okay, now this alpha and beta value of D will be passed to the node I. So here alpha is equal to 10, beta is equal to infinity. So now at this node I, because I is a min player, beta value will be changed. So infinity gets compared with 9. 9 is the minimum. 9 and 12, 9 is minimum. So infinity will be changed to 9 now. And what is the node value of I then? Because compare these two values, 9 and 12, the node value would be 9 now. Okay, now this part is done. Now what I have done the mistake here, I hope you can recognize. It should not be 9. Now you check after changing 9. So whenever we compare 9 and infinity, because I, it is a min player, right? So we are changing the value of beta. Beta is equal to infinity and this left child node gets compared, it becomes 9. So when we compare 10 and 9, it satisfies this condition. That means I should not explore this path. I should not explore this path. This path will be pruned from the tree. Now what would be the node value of I? Only one child is there. So the node value of I would be 9 now. Now this part is over. Now the node value of H is 10. Node value of I is now. Then what would be the node value of D? It is the max player. 10 and 9, max is 10. Now we got up to this one, D, H, I, everything is explored. Now come to the node B. So at the node B, which value will be replaced? Because node B is a min player, so beta value will be replaced by comparing with the node value of D. So here infinity gets compared with this 10. So which one is minimum? 10 is minimum. So you replace with 10 now. Now we got it is 10. Now this B value will be passed to the node child of B. That is equal to E. So alpha is equal to minus infinity, beta is equal to 10. Right? Now this alpha and beta value of E will be passed to the left child of E, that is J. Alpha is equal to minus infinity, beta is equal to 10. At J is a min node. So at this point beta value will be changed. So how to do? So beta value is 10. 10 gets compared with 14. So which one is minimum? 10 is minimum. 10 gets compared with 15. 10 is itself minimum. So no need to change. Only you have to change. Only you have to update the node value of J. What would be the node value of J? Mean 14 and 15. Minimum is 14. Now this is done. Now we have to backtrack to the node E. At the node E, as it is a max player, alpha value gets updated. So alpha here it is minus infinity, it gets compared with the node value of J, that is 14. Minus infinity and 14, who is max? 14 is max. Now you can check this condition. Alpha is greater than is equal to beta. Here we are getting. So what we will do, will not explore the right child of E, which is nothing but EK, as this, not only this leaf, complete sub branch will be discarded from the search process. This we will not explore. Now what would be the node value of E? Because E is having only one child whose value is 14. Definitely the value of E would be 14 now. We got the value of H, I, J, E, D, everything is done. Now you find the node value, find the node value of B. B is having two child, one is D, another one is E. This is 10 and this is 14. B is the minimum node, so 10 is the node value of B. Now we have to move to the node A. So at the node A, which value will be changed? It is a max player, so alpha value will be changed. Alpha means minus infinity gets compared with the node value of B. Okay, so minus infinity and 10, who is maximum? 10 is maximum. So we'll replace with 10. Now this alpha 10 and beta infinity will be of node A, will be passed to the right child of A, because all the left side we have already explored. Now we'll move to the right child. So right child, we will pass this value alpha and beta to the node C. So beta is equal to infinity, and same alpha beta will move to the left child also. Beta is equal to infinity. Here also alpha is equal to 10, beta is equal to infinity till the node L. Now at the node L, we have to which value will be changed, because it is a mean player. So beta value will be changed. So beta is equal to minus infinity. Infinity gets compared with the child, left child of L, which is 5. That is, so infinity and 5, minimum is 5. Then okay, let me change, minimum is 5 here. Now after changing 5, now you can observe alpha is 10, beta is 5. This condition alpha and beta, alpha is greater than is equal to beta. So no need to explore the right child of L. We have to prune it. Okay, now what would be the node value of L here? Only one child is having for L. So the node value, same node value will be passed to the node L. Okay, now we have to move backtrack to the node F. Here it is a max player, so infinity value, alpha value will be changed. Alpha is 10 and here the node value of L is 5. So which one is the maximum? 10 is maximum. Okay, so it is okay as it is because already it is there. Then what we will do, this alpha is equal to 10, beta is equal to infinity will be passed to the right child of F. So here is equal to, for M node, alpha is equal to 10 and beta is equal to infinity. Now at this node M, as it is a mean player, the beta value will be changed. So beta is infinity and gets compared with the left child of M, it is 4. So infinity and 4 is the maximum. Let us change it 4. Now you can check this one, alpha is greater than is equal to beta is satisfying. So no need to explore the right child of M. So only one child is there. So definitely that node value will be passed to the M, the node value of M also. Same node value would be there. Okay. Now we got the node value of L, node value of M. Now you can find what is the node value of F, 5 and 4. The max of 5 and 4, it would be 5 because F is present in the max layer. Now we got the node value of 5. Now we have to move to C node. Okay, so left side of C is completely done. Come to the C node. Which value will be updated here? Because we are following the depth first search, it will move to the complete its depth, then will search the right tree, then will come to the root, then from the root will go to the right subtree. So at the node C, as it is a mean player, beta value gets updated. So infinity gets compared with the node value of F, that is 5. So infinity and 5, if you compare, 5 is the minimum value. After changing, you can observe what is the situation. Alpha is greater than is equal to beta. This condition is satisfying. So we have to prune the child of C. So child of C is G. And the connected children also means complete subtree, means this part will be removed, this part will be removed, this part will be removed, this part complete. Once the child is removing, we are removing, means the complete subtree, means from here to here, we will not explore anymore. So thereby it saves our lot of time. So now what would be the answer? What would be the node value for C? Because only one child is left. So F, whose already node value we have calculated 5. So same node value would be repeated for the node C. Now node C value is 5, node B value is 10. Definitely the node value A value, as it is a max pair between 10 and 5, the max value is 10. So this is the way we can solve this alpha-beta pruning algorithm. We can solve the two-player game using alpha-beta pruning algorithm. But who is the winner here? Winner is the max player, and whose maximum value is, and how we got this 10 by following this path. Then from this 10 we got from this path, this 10 we got from this path, and this 10 we got from this path. So this is the maximum value for the max player. So this is the way we can solve a two-player game using alpha-beta pruning. So the main advantage of the alpha-beta pruning is like it can give the optimal solution, as well as it saves lots of time as well as cost of the search process. So this is all about for this alpha-beta pruning algorithm, and I solved two problems. I hope you might have understood how we are using both alpha-beta parameters for both max and min player, and how the alpha-beta values are passed from the parent node to child node, and the node value of the child node is passed to the parent node, and we are checking the condition alpha is greater than is equal to beta, and when the condition is satisfied, we have to prune the tree. So I hope you might have understood. For the preparation of this video, I referred this horoscope for artificial intelligence. You can also follow it. For your reference, I kept the picture of this book on the screen. So till then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.